Hello everyone, welcome back to KSM 3523 Statistics 2. In this video, I'm going to show you how the concepts that we have learned in Statistics 1 is actually connected so that you have an overview of what is actually we are doing in statistics. Okay. So how is the concepts in statistics are connected? The purpose of statistics is to organize, summarize, and communicate the data or the information to the larger audiences. So what do? When we get a pool of data, pool of numbers, what we do? We have to organize them. So the organization can be in two ways, whether it's either graphical or empirical. When you put them in graphical, when you organize them in graphical, you actually can get charts. The charts can be a bar graph, box plot, or it can be a histogram, pie chart. So there are a lot of ways, graphical format that can be used to present your data or your information. But it just tells you a descriptive level. It just tells you, okay, this is what you have in your data. It doesn't tell you more. So the approach in organizing the information that we get is through empirical approach. So with this empirical approach, what we did is we organized the pool of information into frequency tables so that we can have a comprehensible form of information. When you see the frequency table, you are able to see who is the highest, what is the state that has highest COVID or such things. And then we can convert the information into percentages so that we can help people understand better and give an understanding what is the phenomenon that is happening. But that just stops at providing the count, the frequencies. But let's say that you have a huge data set, a big distribution of data, you want to know more about it. So we can move on to central tendency. We can start to summarize the information to get more idea about your distribution of data. So we use the concept of central tendency, where we can summarize the information, a pool of information, into finding mode, median, and mean. All three are a single value that we get from the big distribution, from the big source of data that we have collected. We have mode, which is we can identify what is the most frequently occurring number in your data set. We have median, what is the middle point, and also the mean, the average of the distribution. And that is not also enough. We want to know about the variability that exists in the distribution. So we started computing measures of variability. So when these two measures of variability can be in terms of range, the variance, or the standard deviation. So what did we do further? We want to know, remember in statistics, we want to make, finally we want to communicate the results. So once you organize, you summarize, you need to interpret. So when time comes to interpretation, you need information to make the interpretation. So what did we do next? We used the mean and standard deviation from the descriptive analysis that we have done and moved on to inferential analysis. So we used the mean and standard deviation information to make more to go into further interpretation or further exploration or further explanation. So that is when we use that mean and standard deviation to convert our raw information, raw data, into different score types. So we change it to z-score. Why? We want to explain whether this particular score that we have is lower than the average, above the average, or is it in the range of average? So we would like to know where do you actually belong to, because you want to make interpretations. So it explains, the z-score helps us to explain where is our location, where is our stand in big population in the sample. Okay. Next is in the inferential statistics, what we did is we used the mean and standard deviation from the raw score. We convert it to a t-score. Why do we need to convert it to a t-score? Because you have questions about comparisons and you would like to answer questions on relationship. When you are looking at comparisons, you looked at if you have one sample and you have a known population mean. Okay, you want to see is it the same? The mean that you get from the population is same with the from the population or not. And then you would like to also make comparison between the same sample before and after. So you would like to know whether the drugs has any effect on the person. So you do measure them before and after taking the drug. So you use the same sample twice. So that's when you use paired sample t-test. And in some cases you would like to test whether there is any difference between two groups. So you look for independent sample t-test. In all these different t-tests, we are looking for comparisons, looking for differences. So all these different tests is actually differences are using mean and standard deviation from the raw score. You change it to the t-score, and then you actually are running you're actually making the conclusion, finding conclusions or interpretation. So for all these different t-tests, paired sample t-test, one sample t-test and independent sample t-test, they have one assumption that is common, which is normality. So all the outcome variable or the dependent variable for all these three different tests are continuous variable, and you have to check for the normality. And how do we check that? Using skewness. So it has to be between plus or minus 2 within that particular range. So for independent sample t-test, it has an extra assumption that you need to check, which is equality of variance of outcome variable. Again, all the assumptions are for the outcome variable, for the dependent variable, which is continuous in nature. So how do we test that? In SPSS or in any other softwares, there are Levene's test for equality, and you have to get the probability value or the p-value greater than 0.05. So if these assumptions are met, then you can start moving on into interpreting your findings, your analysis. T-scores are also being used in relationship studies or in questions regarding relationship. So in your stats 1, you have covered on Pearson correlation. Why did we run Pearson correlation, or when do we run Pearson correlation? When you have two continuous variables. These two continuous variables should also meet the assumption of normality, because these are two continuous variables. You want to know the distribution. Are they skewed or are they normally distributed? Again, there is a skewness criteria to be met. Okay, so ideally, when you have the mean and standard deviation, what we do is we use the raw scores to transform to either z-scores or to t-score in order for us to answer our research question, which at the end of the day is to interpret the results. Okay, when it comes to interpretation of results for the t-scores, there are two things. We have learned hand calculation and also using statistical software. So when you're using hand calculation, when you're using the t statistics and t critical, your t statistics has to be greater than t critical value to show there is a significant difference or significant relationship. The t critical less than the t statistics less than t critical, showing there is no significant relationship. When you're using statistical software, no matter SPSS or you're using R, any other statistical software, when you run an either a one sample t-test, paired sample t-test, independent sample t-test, or Pearson correlation, you need to look for the sig value or the p-value, or known as the probability value. If it is greater than the cutoff 0.05, then it is non-significant. If it is below 0.05, then there is a significant differences or there is a significant relationship that exists. Okay, and this 0.05 is just for 95% confidence. So you can also have it for 0.01. Okay, ideally, what I would like to show is descriptive and inferential statistics are interrelated. All the concepts that you have learned is actually connected, because you start with organizing. So how do you cannot get your T-scores without organization. So you have to start organizing your data. When you find your mean, your standard deviation, then you can use this information from the organized information and converting to either z-scores to identify the location or to explain about your score, or to make comparison or to study about relationship, you can convert it to a t-score. And then the following are just the assumptions that you need to look into for every specific test, and how do you actually interpret it. Okay, hope it was clear. Thank you very much.